Okay, guys. Let's look at like one or two little things, and then that's it.
Hold on, Mr. McGee. Before you start this, let Ben get his camera ready so he can film this and use it on the test.
What?
The Patriots, they filmed other teams and used it to win Super Bowls. Hey, how many Super Bowls has Tom Brady
Okay,
had
enough.
with Spidey? 0.
Christian.
0.
Okay, so
They were all with Spidey.
here we go. I don't know if the book's going to ask you questions exactly like this, but you might bet that my exam will ask you something like this. So I'll probably give you like another worksheet covering this kind of stuff later. We've already talked about this question, so I think you should have a decent shot at it already. Yeah. So, even or odd degree? Odd, why? Because ultimately at the end behavior is
Up and down.
opposite. Like that's that snake kind of shape. No matter what happens in the middle, that tells you that it's odd. Let's also say, is the leading coefficient on all those polynomial terms, if we expanded it all the way out, what would the first coefficient on, like, so it's got to be like x to the 7th or x to the 9th, right? Like, what would this thing be, positive or negative? And why do we know it's positive? Because it starts, it's just like the regular x cubed, isn't it? If it was down here and up there, that'd be a negative coefficient. And then if it was even, that's even easier. You know what a positive parabola looks like, and you know what a negative parabola looks like, so don't make those hard. Okay, so we know it's going to be odd and a positive, I guess I'll write it, leading coefficient. So I'm sure you'll have some problems that probably just ask you that, but probably going to be really easy. Yep. Okay, let's do some more interesting stuff though. Multiplicities for each zero, what's that word mean?
Means how many times each zero shows up?
Yeah, how many times it shows up. Very well. So we got to say like each zero first. So what are our zeros?
Like -4, -2, 3.
-4? Oh, it is -4. Gosh, dang it.
-2, 3, 7.
7.
And then 3 again, because there's 2.
Good. So multiplicity means how many times does each one of those happen? How many times does it look like this one happened?
Just once.
Looks like it's a line right there, so that's probably once.
Once.
This one also looks pretty linear, I think once. This one, at least twice, maybe 4 times. We'll just probably say twice. An even number of times though, since it bounced, right? And then over here, it goes through, so it's odd, but it looks funky. I think it's probably 3 times on that one. Does that make sense?
How could it go through 3 times?
It does what it wants, Gabe.
It's just really short.
I think Gary's got it, kind of. I did what I wanted, right? I just made this up. So if it looks like that snake shape in that little neighborhood, around it, then it's probably either 3 or 5 times. The steeper it is, the better chance it's probably like 5. Does that make sense? That's all. Don't make it too hard. That's all we got to know. I said possible expression for the polynomial. There could be multiple ones because we're not exactly quite sure about some of these things, right? And there could be any coefficient in front. So what's a good one?
X to the 7th.
Yeah, I think we want to make it easier than that.
X to the 5th.
You're going to make it really hard.
X squared.
Well, doesn't it, if it has
I don't think any of those things are good. Okay, you guys hear Kylie?
Hey, how about now?
She said this. And then one of those. 2 of those.
And
So let's see if it makes sense with what's up there. What would the leading coefficient be here? It'd be
it'd be
x cubed, x to the 5th, 6th, 7th. There we go. Do we need to make it negative? No, so I think we could leave it alone. Can we put a 2 in front of there if we wanted to? Sure, that's positive. That would work. We could do anything like that. Is there a way to get this specific value and solve for it? Yes, there is. Should we do that too? I think so. Got time.
no.
It's not very hard.
It's hard.
You can figure out exactly what this is using another point that's on the graph. If you have another point you can see. Can you guys clearly see any other point besides the ones we already used? This one,
-4.
right? What's the coordinates?
0, -4.
Yes. We can plug that in and solve for a. I don't think it's very hard even. Looks like it's going to be bad, right? But just plug it in. So y is -4. What's x?
0.
So it goes in all these spots, right? So this becomes, and -3 squared, and -7 cubed. So this says -4 equals a times, what is all this stuff? Can you guys help me? 8 times 9 is, and that's odd. Negative to odd is -343.
Yeah.
Mm-hmm.
And then I need a calculator. Help me out. When we divide, we're going to get a as positive, aren't we? Positive 4 over something. Big number. 2, 4, 696. Would we have ever been able to guess a? No, but now we know it for sure. So our polynomial, I don't think it's possible anymore. This is exact as long as we were right about those.
I knew it was going to be a fraction because it's going to be very, very shallow.
I knew it was 4.
Because it's like,
That's that number that goes in there. Done. That's the exact polynomial. Okay, I'll try to find a worksheet next week when we start reviewing for our test that has something like this in it. I can find something. I know a few places to look. So this is the good stuff we need to know.
it's
Yours is going to
actually,
be easier though.
a 4
So-
goes into that number, so if you want to make it smaller, it's 1.
Oh, does it?
6,174.
Cool, so Katie reduced it. Okay. One other thing you might need to do is, there's a couple problems that talk about local minimums and stuff. What's that mean? Let's just throw a graph up here. I don't know. Let's just put one on.
X squared plus b squared.
We want one that's
equals
interesting.
7. Ooh, can I put it in? Can I put it in?
Should we put in the one we just did?
Ooh, no, can I put it in?
Let's put in the one we just did and see if it looks right and see if we messed up, first of all, shall we?
Shall we?
So you guys are going to have to help me what it was since I erased it. What was it? The number was 4 over...
4 over 4.
No, it's 1 over here. Do you want to do the 1 over?
No, let's do it.
696.
Oh,
696.
there? Okay. And what else? X. What was it? You guys have it in notes.
Plus 4x. X minus 3 squared.
X minus 7, right? It was over there on the other side. Good. Okay, so it's in there. Let's graph it. My window's funky. So I need to change it. Zoom 6, sorry. Zoom standard. There we go. Isn't that really similar to what we had?
Mm-hmm.
The only difference is I think something funny's happening in here. So the reason I'm putting this up here, besides checking what we just did, is just a piece of vocabulary. So when they say local minimum or maximum, they might also use the word extrema. Either one of those is called a local extrema. How many does this graph have? It's kind of hard to see since it's zero. What do you guys think that means, local minimum or maximum? Any ideas? We'll just take the word local off. What's a minimum or maximum?
High and low.
Yeah, like the highs and the lows, the peaks and the valleys. So this is a max, this is a, and then do we have something else in here at least? So we'll leave those off for a second. We'll get one in a sec. So how could we calculate those? You guys know how to do that, right? So if the problem asks you for that, you calculate and you say maximum, like this one over here is the maximum, right? So left, right. Guess, so getting these is something you guys pretty much already know how to do. So you could say it has a local max. You've got to use that word local. Let's talk about that. A local max of, what's the y value? 6.396. Given 3 decimal places. That happens at x equals negative 3.281. That's how I'd like you to write these, okay? That way I don't have to teach you a new way later on. I don't know what the book does, but that's how we're going to write it. Does that make sense? I mean, I won't mark you off if you write it another way, but just try to do it that way, okay? So that's a local max. We could do the local min the same way. Let's see how many of these guys we have. What should I do with my window to see those ones we couldn't see? I should go, so it should change x's or y's? Shouldn't I change the y's? Maybe go like a real thin window? Let's see that. So now we can't see that one, but we can see this one, for instance, right?
Okay.
And that one, didn't we know the coordinates of this one already? Because it was also a 0. We already know the coordinates of that one. This one we could calculate though if we needed to. So what does it mean what's the word local mean? Here's what it means. It means in some local neighborhood. Does that make sense? So like this guy, is this the all-time minimum for the entire function, the entire picture?
No.
Of course not. If we go back to our standard window, there's no way that's the all-time minimum for the function, is it? I mean, it's not even as low as this. And this thing, is this the all-time minimum?
No, it's infinity.
No, it like keeps going down to infinity. Is there any all-time minimum for this polynomial? Could there be for some of them?
Yeah.
Some of them that go like this, wouldn't they have like, they might go like this, but they'd probably have a bottom, wouldn't they? So all local means is it's a minimum, but only in that neighborhood. Does that make sense?
In between the 2 zeros?
Yeah, you could maybe say in between the 2 zeros. That might, is that always true, Katie?
Well, what if we were to shift it down like maybe 10?
What if it was up here though? Would it be between 2 zeros?
No.
Good idea though. That's a good idea. Okay, so local means in a local neighborhood. If you guys see any of these guys, like you're calculating them, let's say you have a function that looks like this, like an even one, and it goes something like that, okay?
Okay.
This is a local, this is a local, this is a local min, right? But this guy's also the all-time min. So if you see something like that, label it and tell me, okay? So instead of all-time, we're going to use the word absolute.
Absolute
Minimum. Does that make sense? It's just vocabulary, really. I mean, finding those is going to be pretty darn easy.
So on ones like that, would it be like negative infinity be the absolute minimum?
Well, there would be no absolute minimum because negative infinity isn't like a finite thing, is it, Gary?
No.
Good question. But there just isn't one. Good. Okay, that's it. I think we're good.